Learners, greetings. I am Professor Sajid Jamal, Professor of Education at the Department of Education, Aligarh Muslim University, Aligarh. Today, I am going to talk on a very interesting topic, that is measures of central tendency. Dear learners, you have come across with various situations, sometimes in news, sometimes at social media, sometimes at other places like the mean temperature of this week has been 34.7 degrees centigrade or like that, or the average temperature in the month of May in 2025 is lowest in the last 30 years, or sometimes you listen such situation that the average salary of a manager in this particular company is this, or sometimes you listen about the expectancy life, or sometimes you listen about the average national income. So all these basically come under the category of central tendency, and this measure sometimes becomes very important. So let me first clarify what is the measure of central tendency. There are few bookish definitions that have been mentioned on this slide. If you see the first definition that says what is the measure of a central tendency? So a sort of average or typical value of the items in the series, and its function is to summarize the series in terms of this average value. Meaning by what is measure of central tendency? It's a certain kind of average value or typical value, and it is chosen from a series, and it says that somehow most of the values are centered around that chosen value, that typical value. If you come to the second definition, that says a measure of central tendency is a typical value around which other figure congregate. More or less in the same way as the first definition says, that basically measure of central tendency is such a value around which most of the values in that series or in that data lies. If you come forward and see other definition, the third definition says a measure of central tendency is a number which is typical of the whole group, that is somehow it is a representative of the whole group. Coming to the fourth definition, a measure of central tendency is the most representative value of the distribution. That is, this definition says that basically the measure of central tendency will not be very odd, or will not be any extreme, or somehow it will be the most representative value of that particular distribution, of that particular series, of that or that particular numbers. So if you conclude all these four definitions that have been mentioned in these previous two slides, we will come to some conclusions, we will come to some characteristics of the measures of central tendency. Definitely the most important characteristic of a measure of central tendency is that it is an average. So how that average is calculated? Definitely there are so many ways of calculating that average. So ways of calculating average will be different, but every time the measure of central tendency will tell that it is some average value. So it provides an average description of all the scores of a particular group. Let me tell you one example. Suppose I am a teacher, and definitely in my PG class there are 50 students. So I have taken a test. So that test is of 20 marks. So I have evaluated all of their copies, and finally I have got some numbers, like someone has scored 17 marks, someone has 18 out of 20, someone 3 out of 20, someone 5 out of 20. Mostly they have scored 11, 12, 13, 14 or 15 out of 20, something like that. So all the 50 students, they have got some marks. So the moment I will calculate the measure of central tendency, it will be some value which will show the average behavior of the group. It will not talk about the extremes. What are the extreme? Someone is performing very poor, so his or her marks will be 3 marks or 4 marks. So that measure of central tendency will not be that poor, or that measure of central tendency will not be very high, like 19 out of 20 or 20 out of 20. So it will be such a value that will tell that it is the average behavior of that particular group. So this is the first characteristic of the measure of central tendency. Definitely it gives an indication about status of the group. So what does it mean? Suppose I have two groups, in my class. So on the basis of some criteria, for example, place of living, or I have made that criteria on the basis of gender. So I have separated male students differently and female students differently. Now I am calculating their average, and by that average I will be able to tell whether boys have performed better than the girls or girls have performed better than the boys. Are those students who have rural background, they have performed well? Are those students who belong to urban background, they perform well, or something like that. So basically measures of central tendency is certain kind of indication about the status of the group. Coming to the third characteristic, it provides a single value as a representative of an entire distribution of the data. So what does it mean? In fact, the distribution might be of 20, or might be of 30, or might be of 50, or might be of 10, or might be of 5. So that measure of central tendency will be a single value, and that single value will be the representative of the entire distribution. Coming to the fourth characteristic, it enables to make comparison among the groups in terms of performance. Suppose I am an executive in some multinational company. So there are so many managers, like sales managers, like quality managers, like production managers. There are so many managers. So I just want to know who has performed better. So in order to do that, what I will do, I will calculate certain kind of central measure of central tendency, and basically on the measure of central tendency I will be able to tell which group has performed. So basically the moment when I have so many groups and I want to compare those groups in terms of their performance, so that measure of central tendency is a very good criteria on the basis of which I can compare one group from the other. Definitely, coming to the fifth characteristic, it does not provide any information about the individual data, rather it provides summary of the data set. Meaning by, suppose there is a distribution of 50 scores, so it will not talk about one individual score, that is lowest score or the highest score or the middle score. No, I mean it will be talking about the average score. Coming to the last characteristic, it is a measure of central location. So sometimes you will see, if you will go through the internet resources, or if you will go through the books, so in some books measures of central tendency have been mentioned as measures of central location as well. So this is the last characteristics of the measure of central tendency. Now dear learners, basically there are three types of measures of central tendency. By and large, these are mean, median and mode, as has been mentioned on the slide that you can see. Definitely their way of calculation is different, but all the three, they tell certain kind of measure of central tendency, or all of the three basically tell certain kind of average. So out of this, first we will talk about mean, then we will be talking about median, and at last we will be talking about mode. So first I am going to tell you what is mean. We will be taking some definitions, we will be talking about some important characteristics of mean, then we will see how mean is calculated, and similarly we will proceed for median as well as mode. So let's talk about mean. So mean is referred as arithmetic mean as well, and what's the meaning of mean? If you see, the slide says mean is the sum of all the scores oblique measures scored by the individuals in the group divided by the total number of individuals. That is, how many data you have in the data set, for example 5. So what you have to do? You have to find the sum of all the 5 and divide it by that number, that is 5. So you will get M, that is the mean. So mean is represented by the symbol M. Suppose there are 11 players in a team, and how much runs they have scored. So all the 11 scores we will write, we will find the sum and divide it by 11. So we will get the mean. So how we get the mean? Simply we sum all the scores that are there in that data set and we divide by the number. So by that way we get the mean. There are some standard definition of mean. So the first definition, arithmetic mean or mean is the value obtained by dividing the sum of all the values by the total number of values. Just now I have explained. The second definition is more elaborately saying that arithmetic mean of a distribution is the sum of all the values of the variable divided by the number of values. So simply, how many data are there in the data set, you just sum it up and divide it by that number, so you will be able to get the mean. So it can be represented by this mathematical formula. So M, as just I have mentioned, is sum of the items divided by number of the items. So sum is represented by the Greek letter summation. Sometimes it is also called sigma. So it is capital sigma. So capital sigma or summation x upon n. So this summation shows that how many data are there in the data set. You have just to sum it up and divide it by the total number of data that is available in that data set. So that is n. Now let's do some calculations, some examples I have taken for you. So if you see the first example that is there, two examples have been mentioned on this slide. There are numbers. So 11, 17, 13, 9, 15, 7 and 90. So if you find the sum, let me mention 11 plus 17 plus 13 plus 9 plus 15 plus 7 plus 90. 15 plus 7 plus 90. So remember, you have to calculate the mean. So M is equal to, remember how many numbers are there? So 1, 2, 3, 4, 5, 6 and 7. So you have to sum all the 7 numbers and divide it by 7. So now let's calculate. So 11 and 17, that becomes 28. If you will add 13, so it will become 41. Then 9, 50. Then 15, 65. Then 7, 72. And further you add 19, so it becomes 91. Now what you have to do? 91 divided by 7. So finally, if you will divide 91 by 7, so you will get 13. Now the mean of these numbers, that is the mean of 11, 17, 13, 9, 15, 7 and 19 collectively becomes 13. Now let me tell it to you that this 13 basically shows the average value. It shows the average value. It does not talk about any extreme thing, but it is the truly representative. It is the truly representative. Truly representative. So this is how we calculate the mean. Find the sum of all the numbers, see how many numbers are there, divide that sum by that number, and by that way you will be able to calculate the mean. Now let's proceed to the second one, second example that was shown on the slide, and let's find out what we are getting the mean. So if you see the second example, numbers are 18, 23, 18 plus 23 plus 11 plus 14 plus 16 plus 28 plus 7 plus 28 plus 7 plus 16 and plus 20. So these are the values. Count how many numbers are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers were there. So divided by 9. Now what next we have to do? We have to calculate the sum. So calculate. So what you will get? So let me calculate. 8 plus 3, 11 plus 1, 12 plus 4, 16 plus 6, 22 plus 8, 30 plus 7, 37 plus 6, 43 and 0. So 3 carry 4, 4 1 5, 5 2 7, 7 1 8, 8 1 9, 9 1 10, 10 2 12, 12 and 1, 13, and 13 and 2, 15. So by that way, the sum is found out to be 153. So 153 divided by 9. So the moment you will divide, you will get 17 as the right answer. So meaning by this 17, in fact, is the mean of this data set. This data set, that is, we were given 9 numbers: 18, 23, 11, 14, 60, 28, 7, 16 and 20. We found the sum, divide it by the total number, that is 9, and finally we got as 17. So through these examples, I am quite sure you will be able to understand how to calculate the mean, but we will take few more examples so that you may be perfect in calculating mean. So let's proceed to the next slide. So here we have taken some more examples. The first case, if you see 10, 8, 9, 12, 16, 13, 14, 19, 17 and 18. So count how many numbers are there. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are total 10 numbers. Now in order to calculate the mean, what you will do? So mean is equal to, as I have written, summation x upon n, that is, you find the sum of all the numbers and accordingly divide that sum by the total number. So the moment you will sum all the numbers, I think the sum will come out to be 136, and since there are 10 numbers, so finally you will divide 136 by 10, so finally you will get 13.6. So remember that it's not necessary that mean is always coming to be a whole number. Mean might come in point also. Here the interesting thing is that if you see the data, let me play it again. If you see the data, so again see the data, the numbers are like this: 10, 8, 9, 12, 16, 13, 14, 19, 17 and 8. So if you see all these 10 numbers, you will not find that there is any number which is written in decimal. But interestingly, the mean of this data is coming out to be 13.6. So don't be confused. It might happen that the mean of any data set can come to be such a number which is not there in the data. So you need not to worry. This 13.6 shows the average value, and this shows the average behavior of that particular group. So this is how we calculate the mean. Let's take the second example. In the second example, basically the numbers are a little bit big. Numbers are more as well as bigger numbers I have taken. So if you see, it is 55, then 80, 76, 88, 43, 51, 62, 71, 30, 91, 33 and 56. So if you count how many numbers are there, let me count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and finally let me count it again. So 155 is 1, then 82, 76 3, 88 4, 43 5, 51 6, 62 7, 71 8, 39, 91 10, then 33 11 and 56 12. So there are total 12 numbers. So the procedure will be same. How you will do? Same formula you will use, that is, you have to sum all the numbers and divide it by 12. So here this time the number is 12. So if you go on calculating, you will find that the sum this time is found to be 736. So don't be in hurry, just have patience, find the sum with patience, take your own time. You will find that the sum comes out to be 736, and if you will divide 736 by 12, you will find that it comes to be 61.33. Again, it is a very interesting case as in the previous case, that in the data set definitely there was no such number which was there in the decimal. Let me play it again. If you see example 2 that is there on the slide, there is no number in the data set which was in the decimal, but finally the mean has come out to be 61.33. So this is how we calculate the mean. In order to make the thing sure that you have understood how to calculate mean from ungrouped data, let me come to the third example. Again, it is a little bit bigger, numbers are more. So let me repeat the numbers: 43, 57, 91, 97, 54, 33, 30, 67, 50, 58, 67, 75, 78, 80 and 37. So have you counted out how many numbers are there? I think you will agree with me that this time I have taken 15 numbers. So the first number is 43. So you will add 43 to 57, then you will add 91, then you will add 97, then you will add 54, then you will add 33, then you will add 30, then you will add 67, then you will add 50, then you will add 58, then you will add 67, then you will add 75, then you will add 78, then you will add 80, and then you will add 37. So finally the sum will come out to be like that. You do it. You follow me? So here n is 15 and the sum comes out to be 917. So next time what you will do? So you will divide 917 by 15. So finally you will get the mean as 61.13. And again the mean has come out to be a number which is represented in decimals. So in a nutshell, through all these 5 examples, what you have understood? Definitely how many numbers are there in a data set. If you are about to calculate mean, what you will do? You will find the sum of all the numbers and then divide it by that number. So finally you will get the mean. This example, all these examples that have been taken today, in fact, they are ungrouped data. So in various situations we find some grouped data. And what is a group data? A group data is that data in which we have class interval and frequencies. So how to calculate mean from group data? Definitely I will be telling you later on. At this juncture of time, just I want to discuss something more about the mean. So what are those things that I want to discuss with you about the mean? It is very important to know when to use mean. As in the beginning I said that so far as measures of central tendency is concerned, there are 3 ways: mean, median and mode. So there are some situation in which mean is very suitable, some situation median is very suitable, and in some situation mode is very suitable. So when to use mean, I think through these 4 points you will be able to understand. First point, when the scores are normally distributed in a data set. So what is a normal distribution? Normal distribution is this. So what it says, that this is the mean, and this normal distribution shows that basically if you will move towards the right side of the curve, these are good scores, and if you will move towards left side of the curve, there are some poor scores, and mean is exactly in the middle. So if there is any population or if there is any data set in which you find that normal distribution is there, that is extremity is not there, that is all the scores are very high or all the scores are very low, this is not the situation. Some scores are very high, some scores are very low, and most of the scores are average or centered around average or centered around mean. In that situation, comfortably you can use mean. In that situation, mean gives very good result. Then coming to the second point, when there are absence of extreme scores, outliers. So what are outliers? Let me write you 5 numbers: 1, 2, 3, 4 and 100. Now if you see, there are 5 numbers. First number is 1, second number is 2, third number is 3, fourth number is 4 and the last number is 100. So if you see the successive difference between first and second number, or second and third number, or the third and fourth number, it is 1. But if you will find the difference between fourth number and fifth number, it's very huge, it is 96. So by that way, we can say that 100 is an outlier. It is an extreme value. So if this will be the situation, we will not get a true value, exact value of mean. That mean will not be the true representative of the whole data. In that situation, we will use another measure of central tendency, about which I will be talking in the next class. So in a nutshell, when to use mean? When the scores are normally distributed. Number 2, when there are no outliers, and when the most stable measure of central tendency is needed, or some further statistics are needed to be computed. For example, you want to calculate standard deviation, you want to calculate analysis of variance, you want to do regression analysis or something. I mean, these are the advanced statistics about which you will be known in the coming classes. So if further statistics you require, in that situation, mean will be very better, very best in fact, and you can use the mean. Similarly, there are some disadvantages of mean as well. There are some situations in which it is not advised that we should use mean. One such situation, definitely I have discussed about the outliers. Remember that whenever the outlier will be there, your mean score will vary a lot. So if you find just by your observation, just by seeing the data, if you think that outliers are there, don't use mean. I mean, it is one of the biggest disadvantages of mean, that it does not give good result in case of extreme scores or in case of extreme layers. Outliers. Then it does not provide information about individual item. In fact, in the beginning, when I explained about the measure of central tendency, I told that any measure of central tendency does not talk about individual scores or individual items, rather it talks about the average. So this is one of the disadvantages of mean. It's very difficult to represent mean graphically. I mean, this is the third disadvantage. And if you talk about the fourth disadvantage, it cannot be applicable for open-ended classes. I mean, usually when the data is numerical, when the data is quantifiable, in that situation only mean can be used. And finally, sometimes it creates biasness. So how it creates biasness? A group of class always includes some very good students, some poor students, some and most of them are average students. So sometimes mean comes to be very close to higher one, or sometimes mean comes to very close to lower one. By that situation, sometimes mean also create biasness. So these are the 5 big you can say disadvantages. But in spite of these disadvantages, mean is supposed to be one of the most important measure of central tendency, and in most of the researches in education and psychology and social sciences, you will find that mean is used. Not only there, I mean, at so many places in government data, in government statistics also frequently we use mean. So this was all about mean. So in this class, what you have learned, what is the measure of central tendency? What are the characteristics of the measure of central tendency? What are the types of measure of central tendency? And I told that there are 3: mean, median and mode. Then I came to talk about what is mean. I took some example and told you how to calculate the mean. So with this, today's class is over. In the next class, we will be talking about another measure of central tendency, and that is median. So thank you very much for being with me. Wait for the next class. Thank you.